All right. Now we're going to talk about the RIE system. First, we're going to start with basic starting up the system. So we're just going to go left to right. Basically, all of these components are a part of this main system. So it's all modular. So first, we're going to turn on the exhaust valve controller. We're going to turn on the pressure relay. Oops, wrong one. Gas flow controller, RF power, and the tuning system. Finally, on switch in the back for the main RIE. Right, that's it for. Right, now on the other side, we're going to turn on the cooling water. So both of these, you can see this is where the water comes from and this is where it drains. Your nitrogen 95, this runs your pneumatics. Turn on the main breaker for this rotary pump. And then your nitrogen 99, vent gas. Additionally, we're going to turn on our process gases. We have oxygen here. Turn on the main cylinder and then open it to the gas lines. We're also connected now to CF4. Same thing. I'm going to turn on the cylinder and open it to the gas line. All right, that's it. All right, so now we're going to perform a couple simple operations on the chamber. The first one we're going to do is 90 watts oxygen plasma. So we're going to set our power to 90 watts. We're going to set our pressure set point, the working pressure in the chamber, to 450 millitorr. We're going to set our flow of the oxygen to max. The reason we're going to do this is because the oxygen line is leaky. So before we do oxygen, we have to first flush the gas lines. So we're going to open up our gas line here. And I'm going to set a timer for 2 minutes. After about 2 minutes, it should completely purge the gas line. All right, so it has been 2 minutes. We've purged the oxygen line. So what we're going to do is we're going to turn off this, allow the pressure to return to a good base pressure. Meanwhile, we're going to turn this down to our operating flow rate. For pure oxygen plasma, we're going to use about 30 SCCM. You see it's going to do some feedback to get it there. Now, before we strike a plasma, or before we start flowing in our process gas, we want our pressure to be below 200 millitorr. And depending on how long it has been since we last used the system, this could take, 5-10 minutes. So we'll be back when that happens. All right. So right now we're at 200 millitorr. I'll say right now you can get this system down to about 150 millitorr if you use it regularly every day. At this time, it's been about a week since this has been used, so it's taking a very long time to pump it out due to the moisture that absorbs into the sidewalls of the chamber. Right now, we'll be able to strike a plasma with this. So the way that we do this is we turn on gas 2, which is the oxygen. We turn on the set point interior. So when it's set to interior, it will control this valve that connects to the vacuum line. It will control how open or closed it is to make sure it stays at the set point pressure. So for example, if you're much above the set point, it will be completely open. If you go overshoot and go far below it, it will close off the vacuum line. And it's basically just an internal feedback system that happens within this controller. So once it gets near our set point pressure of 450 millitorr, we can strike our plasma. It's going to pump down. The set point is at 450 for oxygen plasma. And the set points that you want and the flow rates, etc., this can all be determined from the literature. So there's a lot of different etch recipes explaining what the working pressure should be, what the flow rate should be, all that stuff. Um, in addition, we also have some known recipes that we use pretty often, and you can follow those for this system. But if you're trying a new recipe, it's good to reference the literature first and then kind of try it out on this system. So as you can see now, it's overshot our set point. We have a percent error shown on this dial. So the feedback system is now closing that valve so that the pressure can rise as we flow more gas into the chamber. There we go. It usually takes a minute for it to actually actuate and get to the set point. So at about this pressure, we should be able to strike our plasma. So we're set to 90 watts. We just press this red button. At 90 watts, the plasma is very dim. You can hardly see it. Oxygen plasma is going to be a bluish white. Now, while you are using the RIE, you may have to actively tune it, which is what this system is for. So you're going to tune it with the phase of the RF power being fed into it. So right now, you can see the reflected power is 0. If I click this to the left a few times, you can see now there's a reflected power of 4 watts, meaning that it's not properly matched. So if I click it back, you can see it goes back down to 0 watts, indicating that our load, i.e. the gas in between the two capacitive plates of this RIE, is matched to our RF line that's feeding it. So that's an oxygen plasma. I'm going to turn off the RF power, turn off the gas, and turn this back to the external set point. This is just going to keep the vacuum line open and pump down the chamber as much as possible. Next, what we're going to do is we are going to strike a CF4 plasma. CF4 plasma is going to be at a higher power. This system, we usually go up to 300 watts. And depending on Passion's curves, you can determine what pressure and power you require to strike plasma in this system. So when we're doing a CF4 plasma, we're going to do 300 watts, and we're going to set it to a set point of 350 millitorr. So as you can see, now that we've used the system a little bit, the pressure is able to pump down quite a lot more, whereas before it couldn't get past 200. So now we're just going to do a plain CF4 plasma. So same thing, we're going to turn on gas 1. Gas 1 is set to 22 SCCM, so it's going to do a feedback within the mass flow controller to ensure that's happening. And then we're going to set this to the internal set point, that it goes to 350 millitorr to do our working pressure for CF4 plasma. So this system is able to do 2 process gases at one time. Typically, that's some sort of fluorine gas and then oxygen. Additionally, you could attach argon or even chlorine if we have the proper safety procedures. But in general, it's going to be only 2 at one time. That's something to consider. So it's going to pump down to around 350, and then we'll strike our plasma. All right, so we're approaching our working pressure set point. We're going to strike our plasma. And right away, I can tell you that is not entirely pure. You saw it kind of flash pink briefly. That indicates that there is an inclusion of most likely nitrogen, i.e. that's going to be atmosphere. However, you can see that color kind of faded, and it went to a bluish white. This is the proper color for a CF4 plasma. So again, you can actively tune it. If I get this out of sync, now we have a reflected wattage of 6 watts. I'm going to bring it back. and actively tune it to make sure that our reflection power is at 0 as much as possible. Again, this has to do with matching the transmission line from this RF power source to the load of our process gas. So we ran that plasma for a little bit. We're going to now turn it off. And again, we turn off the gas, and we switch the valve controller to the external set point so that it can bump down all of our process gases before we vent out our system. Now, once it reaches our base pressure, which was 190, that's the point at which we're kind of satisfied with it and we'll vent out our chamber. At that point, we would just open this vent toggle and close the vacuum toggle. This is going to feed nitrogen gas into the chamber. Although since we're not, do you want to actually open it up? Oh, okay, so we'll open it up. All right, so close this, open this. And this is going to take a couple minutes to vent out. There's a couple ways you can tell if it's open. The most obvious of which, you'll see this seal kind of come loose. So this line between the top of the chamber and this stage is going to get a little thicker. You'll also be able to actually audibly hear the vent gas entering the chamber. That's just a couple ways you can know if it's already ready. In general, like I said, it's going to take a couple minutes to vent out completely, and then we'll be able to open the chamber. Oh. Yeah, you want to open it? There we go. So, yep. So you can see when I turned off the vent, you'll hear that hissing sound stop. We close it. We open up the vacuum. You see now it's vacuuming this chamber back down to our base pressure.